have one. I don't know if it's any good. Here's 4.3. This is rotation. This is the last. This is the last of our types. No, it's not the last of our types. There's one more type. But I think we do it later. Because, yeah, 4.5 we do it a different chapter. So rotation. Okay, there's some definitions. There's center rotation and angle of rotation. And again, we're gonna limit it. We're not gonna have just everything under the sun. We're gonna limit your angle of rotation. And we're going to limit your center of rotation, actually. Technically, the center rotation can be anywhere on the entire graph, although usually you use the origin to be the center of rotation because it's the easiest. And technically, in the real world, you can redefine your center to be an origin so you can make the math easier. Although if you use a computer, of course, it can do all kinds of stuff. Okay, center rotation, angle rotation, I think that's it. We got rotational symmetry. That is terrible. And I don't think you ended up having a symmetry problem on the last one, did you? Okay, this one is even harder to eyeball than the last one. And so again, if you can't get it, just do the formula. And we'll write down the formulas too in a second. Right, a rotation is a transformation in which the figure is turned about a fixed point called the center of rotation. So this would be the fixed point. Okay, on a carousel, the fixed point is in the middle, right? If you stand in the middle of a carousel, what happens? You spin, but you don't actually leave your spot, do you? If you're on the edge of the carousel, you actually can see like different scenery, right? You're spinning, but you're actually moving. The further away from the center, the further you move. Of course, we're talking about a circle there, so you're always going to end up at where you started. And that's the same thing with rotation. If you were to rotate something 360 degrees, it would look exactly the same. Okay, angle of rotation. Rays drawn from the center of the rotation to a point and its image form an angle of rotation. Okay, the angle of rotation can be any degrees. We're going to focus only on these right here. And this is I'll go over the symmetry in a second. Go ahead and copy down these. It's also in your book on page 173. But you're going to need these formulas, and I want you to notice that this is always going to be counterclockwise. These formulas are for counterclockwise. I will show you the formula for clockwise, but these are for counterclockwise. In math, usually we do things counterclockwise. In the United States of America, we like things clockwise for some reason. But that's just not how math works. Although, honestly, a lot of you guys could care less about clockwise, right? Do what now?
It's the right way.
Clockwise is?
Yeah.
Well, just like I guess the metric system's the wrong way.
What was the last one that we did after rotational symmetry?
Yeah, we'll get to those too, yeah. But your test will be counterclockwise. So, and when you get into algebra 3, you're going to learn a new kind of graphing that's going to be counterclockwise as well. And of course, the kind of graphing we do now is counterclockwise, right? If I have my x-axis and my y-axis, do we remember that this is quadrant 1, this is quadrant 2? Remember doing that, yes?
Yeah.
So it goes in counterclockwise, right? And if you think about it, this is the real world right here. It's always positive. And this one's the next one you kind of get to where you have your number line, positive and negative. Okay. And then these are kind of the evolution of what was invented. So it just kind of makes a little sense-ish. Okay, we'll go over how to do this, but again, if you cannot just see it, which this is really hard to see, do the formula. Okay? Don't get confused by the formula. I'm not going to make you memorize these formulas. I want you to be able to use the formulas. Okay? And imagine if I move the center, how bad it would get. I'm not going to move the center off the origin. Just use the formulas. I'll show you how to use those formulas in a second. We do have other definitions. And on your assignment, we're going to definitely have our different symmetries together. So there's rotational symmetry, there's center symmetry. Rotational symmetry, a figure in a plane has rotational symmetry when the figure can be mapped onto itself by rotating 180 degrees or less about the center. Okay, the point is the center of symmetry. So it's basically, okay, so if I had a shape like this, okay, I'm going to put could I rotate this 90 degrees and it looks the same? Yeah. Could I rotate it 180 degrees and it looks the same? Okay. How about if I rotated this? If I rotated this 180 degrees, would it look the same? It would be an upside down triangle though, right? That's not the same. Okay, that's kind of how that works. Let's look at the formulas and make sure you can do the formulas. Okay, and again, if you can't eyeball it, and this is really hard to eyeball for most people, not everybody, for most people. So it might involve paper, and that's okay. It's not a lot of work. So if I want to rotate this, and I know you don't have graph paper at your seat for the notes, okay, if I want to rotate this shape right here that you can't see, and I want to rotate this 90 degrees clockwise, counterclockwise, where's it going to be, first of all, if I rotate this 90 degrees counterclockwise?
It's going to be in the third quadrant.
Yeah, it's going to be down here, right? Okay, is it going to be a mirror image?
No.
So it's going to somehow like lay down. So, you know, some people can look at this because it's, you know, basically this point right here is going to rotate So it's going to look like, and this is what I mean by it's hard to eyeball. What is that going to be? 1, 2, 3, 4, 1, 2. So it should be, I believe this is what it should, that point should rotate to there. Okay, little harder to look at. So what I would do if I were you, and this is probably what I'm going to tell you, if you can't see it, which most people can't, I'm going to use these formulas. So 90 degrees, let's just write down the points real quick. What is this point? 1, 2, 3, 4. 1, 2. So that's 4, 2. I guess that's a negative 4, 2, right? That's the first point. Next point is a negative 6, 2. Next point is a negative 4. You guys are good. All right. Which formula am I using? I'm going to take my AB and I'm going to turn it into negative BA. Okay, I'm zoomed in or something. Okay. Don't make these formulas hard. It's not hard. So this means to switch. This is AB, right? This means to switch the order. And then what do I do the opposite of? Which number? B. So if I switch the order, and some people need to do this in 2 steps, and that's fine. I'll do this in 2 steps. So I'm going to switch the order first. So that would be what? 2, negative 4. And then B is 2, right? So then I need to change this to... Okay, let's see if that's right. Negative 2, negative 4. Okay, I did it right, didn't I? Yeah. So I was able to eyeball it, but I cheated by eyeballing it, and I drew a line, and then I counted basically a triangle and moved it over. Like I use techniques. I don't like to just look at it, and apparently on the computer you're not going to be able to draw this little cheat line, right? Or I'll count it wrong, right? Yeah. So I might have to do my formulas, and that's okay. Go ahead and do the next 2. Yeah.
So I understand how it gets from negative 4, 2 to 2, negative 4, but what makes it go to negative 2, negative 9?
It says to do the opposite of whatever that is. And that is a 4.
Oh, okay.
It's,
How did you get
yeah, I accidentally closed my 4. So this means to do the opposite. And so if you want to know how to do it clockwise, which it won't be on your assignment, so it doesn't matter. But if I go counterclock 90 degrees, I could go clockwise how many degrees to get here?
270.
270. If I go counterclockwise 180, what would it be to go, counter 180, what's clockwise? 180. If I do counter 270, what is it clockwise? 90. Okay. And this is easy. When it gets hard is when it's on the line, and you have to rotate it when it's on the line. Okay. What are my answers here? Are the formulas that easy to use? Okay, make sure you have it out. Make sure you have it written down.